Today's topics, we're going to cover the finance portion of 1324, which are simple interest and compound interest, and also some annuities. Okay, these are the topics that we're going to cover: simple interest, compound interest, future value annuities, and present value annuities. Simple interest. Simple interest, the INC stands for interest, the PV stands for present value, R stands for the interest rate, and the T stands for time in years. Okay, now there's two formulas for simple interest. Okay, this is the one on the left, that's one of them, and then we're going to derive on the right with another formula by plugging in the PV, RT for the interest. We're going to factor out the PV, which is the present value, and what's left, 1 plus RT. So these are my two formulas, the one on the left in blue and the one on the right. And they all mean the same thing, except for the future, for the FV means the future value or the sum of the principal and the interest earned. I like to call this the future value, the present value, the interest rate, and the T. What we have to know about these type of formulas is that the time has to be in years. For example, if it give you in months, you put it over 12. If it gives you in days, you put it over 365 or 360, depending on what the problem is asking for. Okay, because at times they let the days be 360 per year or 365, but they will let you know. If it's weekly, then it'll be the weeks over 52. Also, the interest rate must be in a decimal. So, how do you convert the percentage to a decimal? You move the decimal place 2 places to the left and drop the symbol. Or even if that's kind of hard for you, you can divide the percent by 100 and drop the symbol. For example, 5% will be equal to 0.05. Okay, now let's do some examples here. Example 1. Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle. How much interest did Martha pay? So which formula should we use? The interest formula or the future value formula? Doesn't matter. No, it doesn't matter. Okay, I'm going to do this example using both formulas. Okay, so let's first start with the formula on the left, which is the interest equals to the present value times the interest rate times the time. If we use this formula, right, to find the future value, then the future value equals to present value plus the interest. Okay, so these two formulas go together. This is to find the interest, this is to find the future value. Okay, now this is what I tell my students, to write down all the variables. And then from the word problem, you're going to extract the information. For example, here it says, find the total amount that Martha paid to her uncle, which is a future value, and how much interest did Martha pay. So by using this formula on the left, we're looking for the interest that Martha paid. So the present value is the money that she borrowed will be $12,000. The interest rate will be 3.5%. To put it as a decimal, it's going to be 0.035. And the time, right, it's already in years, so it's going to be 5. So all we do is plug into the formula, right? We plug everything in, and we use a calculator. So this is our result, 2,100. Now, to find the future value, it's going to be the present value, how much money Martha borrowed, plus the interest that she paid, which will give us $14,100. So to answer the questions, which is find the total amount that Martha paid to her uncle, is going to be $14,100. And how much interest did Martha pay? We're going to use, right? So it's going to be $2,100. So I tell my students that it's up to them which formula they want to use, in this situation. Now, I'm going to do this very same problem again, but I'm going to use the other formula, which is the future value equals to present value, parentheses 1 plus RT. Okay, now if we use this formula, right, this is the future value, but then to find the interest will be future value minus present value. But for now, right, we're looking for the future value. So this is my present value, the 12,000. the interest rate is 3.5%, and the time is 5. So we just plug into the formula, plug everything in, and use our calculator. So it will give us the 14,100. That's the amount that Martha will pay back to her uncle. Okay, now this is a formula that goes with the future formula, which is the interest. The interest equals to future value minus the present value. So the future value that Martha had to pay was 14,100. So how much of it was interest, right? So we subtract the present value, which was 12,000, right? So once we do that operation, it's going to give us 2,100. You see, we got the same thing for both, for the future value and for the interest. So it doesn't matter which one you use. So the total Martha paid was 14,100, and the interest that she paid was 2,100. Okay, now let's go to another example. Example 2. Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25% simple interest to have enough to pay the tuition bill? Hey guys, in this situation, it does matter which formula to use. Okay, we have to use this one here because here Mariana will need to pay a tuition bill of $7,500 in 10 months. So this is the future value here. So in other words, we're looking for the present value, because it says here, what dollar amount can she deposit today? Today is the present value, right? So we're looking for the present value. And the future value is what we need to have in 10 months, which is 7,500. The interest rate will be 1.25%. Convert to a decimal, it will give us 0.0125. And the time, right, the time is in months. So we're going to put 10 divided by 12. Here's a common mistake that students make. They just put 10 here, which will give them the wrong answer. All right, and I repeat, this was at the beginning of the presentation, that the time has to be in years. So if they give you the time in months, you put the given months over 12. Now all we do is plug into the formula. This formula is the one that they use in the book, okay? Which is, this is the future value, and then we have 1 plus 0.0125 times 10 divided by 12, which is a 1 plus RT. That will give us 7,500 divided by 1.0104166667. So that's my answer. Rounded out to your nearest penny, it will be $7,422.68. But like I tell my students, there's another way to get the answer by using the formula without actually solving for PV. This will be easier to put in the calculator. Okay, this is what I tell my students to use. I'm going to plug in parentheses 1 plus 0.0125 times 10 divided by 12 close parentheses in the calculator. That should give us 1.01041667. Now on your calculator, you're going to hit the inverse key. When you hit that key, right, this is what you should see in red. You should see answer to a -1, which means we got the inverse of this. And then we're going to enter 7,500, and it'll give us the answer. You see, we got the answer, guys, without leaving the calculator. At times, students, they don't know how to use a calculator that well. That's why if they use this formula, the one that they use in the book, they have to write every step down. That way, they'll be able to get the right answer. And you never round off until the very end, because if you round off here, say at the 1.01041667, if you round off here, you're gonna, the answer is gonna be off like a little bit on the cents, because they want you to round out to your nearest penny or the nearest cent. So you never round off until the very end. And by using the alternative way, which is here on the bottom, you can never go wrong, because all you do is put in the calculator and use a steady flow of the calculator without actually stopping the calculator. And I believe towards the end, this is how I'm going to be showing you guys, okay, how to use your calculator. Here's another one, simple interest continue. This is example number 3. John received $10,000 loan from his aunt to buy a car. His aunt charged him 2.5 interest. How long was the term of the loan if the interest accrued was $125. So here, guys, it doesn't matter what formula to use, because this formula, we have to use the INT equals to PVRT, because this is the interest accrued, which means the INT, which is the interest, was 125. But here we're looking for the time, because it says how long was the term of the loan if the interest accrued was 125. So again, we're going to put every variable down. Okay, like I said, here it does matter. I'm going to put every variable down. What is given and what are we looking for? We're looking for the time. So the interest accrued was 125, but the present value is 10,000. The interest charge was 2.5%. Convert to a decimal, it will give us 0.025. And the interest accrued was 125. Let's plug everything into the formula. Right, so we multiply 10,000 times 0.025, so it was going to give us 250. On the left side, 250t. We divide both sides by 250. And the answer will be 1/2, or 0.5. This means there's going to be half a year, right, or 6 months. One or the other is correct. That's how we solve these type of problems. Like I tell the students, that you always write the formula down, but make sure that you have the correct formula. And then after that, you extract all the info from the problem. And they're going to be asking for what they're looking for. Every time they're going to be asking, for example, here, how long was the term for? So we're looking for time. But every time they're going to give you all the info except for what you're looking for. Okay. Now comes compound interest. Simple interest and compound interest, they're now in section 5.1 on the new edition. In the past, simple interest was 5.1 and compound interest was 5.2. Now they have them together. So these two types of interest are in section 5.1 of the 1324 book. Okay, for compound interest, if you notice, it's going to be a different formula. It's going to be future value equals to present value, parentheses 1 plus r divided by m to the power of mt. But it's easier to use a formula on the right. The future value equals to PV 1 plus I to the power of n. So the FV stands for the future or maturity value. The PV stands for principal or the present value. The R stands for the interest rate, but you have to convert it to a decimal. The M, here's what's different. The M is the number of compounding periods per year. And T is number in years. Here's where the I replaces the RM in the formula. So the I is the interest rate per period. And N is the total number of compound periods, okay, which is M times T. Now, these are the key words for compound to put in the value of M. If the problem reads yearly or annually, M is equal to 1. If it states bi-yearly or semi-annually, M is equal to 2. Quarterly, M is equal to 4. Monthly, M is equal to 12. Weekly, it will be 52. Daily, it will be 360 or 365, depending on how the book wants you to answer it. If you want you to put 360 or 365. And then continuous is a different formula, which is FV equals to PV, E to the RT. Okay, now, how do we use these type of problems in real life? Compound interest can be used to invest a certain amount of money without depositing additional money. It's like I tell my students, it's like, for example, say that you get like say like $10,000, okay, like somebody gave you that money, but you don't need that money at this time. So what you can do is you can put it in a bank in an account, earning compound interest. You don't have to deposit additional payments. It's just you put the money in the account for so many years and let it earn some interest for you. So this is a type of a formula that we can use for that particular situation. Okay, here's an example. Say you deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much money will be on your account after 5 years, and how much interest did you earn? So remember, if it says compound interest, this is the formula for compound interest. So we're going to use the one on the right because it's easier to enter in the calculator. Okay. So there's always 7 things that have to be accounted for. Future value, present value, my R, my M, my T, the I, and the N. Here we go, guys. So here, guys, what are we looking for? How much money will be in the account after 5 years? So we're looking for the future value. So the present value must be the $1,000. The interest rate is going to give us 6%. Converted to a decimal, it'll be 0.06. The M, right? The M is compounded, here we go, quarterly, so it's going to be 4. The time is in years, we're going to put 5 for T. Now the I is R divided by M, which will be 0.06 divided by 4, which will give us 0.015. And the N is M times T, which will be 4 times 5, which will give us 20. Now we plug everything in the calculator, right? I mean the formula, and put it in the calculator. Like I tell students, you put it in there just the way it looks, and just enter, and this is your solution. But you have to round off to the nearest penny or the nearest cent, which you always go to the third place. I mean to the second place, right? And in the third place, the decimal is 5 or more, you can add 1 to the hundredths place. So this particular situation will give us $1,346.86. That's your solution. So after 5 years, this is the amount in the account. Okay, now, so how much interest did you earn? So we're going to use a formula from the other simple interest formula, which would be the interest earned is equal to the future value minus the present value. So we got $1,346.86. We subtract what we deposit into the account, which was 1,000. So that comes out to $346.86. That's how much interest you earn. Okay. Let's do another example. Now this is continuous. Okay. The last example was compounded quarterly. And let me go back real quick to the previous one. Because remember, we got, let me go back. We got $346 of interest, right? I'm going to write that down. We got 346. So I can show you how the banks at times work. Okay, let's write it down. It's the same problem, but we got 346 and 86 cents. Okay, now this is the same situation now. Same situation, but it's compounded continuously, which means without stopping. Like I tell my students, the more times it's compounded per year, the more interest you're going to get. Okay, so most of the times what the banks do is that when you're going to borrow some money from them, it's compounded like continuous, or maybe like a whole bunch of times. Why? Because they get more money from you from interest. But when you deposit some money in an account, right, that you want the bank use your money, they'll compound it maybe once or twice a year, because this way they don't have to pay that much interest. And here's how I'm going to prove it to you guys, right? It was compounded quarterly, which was 4 times a year, and we got $346.86 as interest. Now let's see what we get when it's continuous, right? It's a different formula. So we're looking for the future value. The present value is the same as before, 1,000. Same interest rate, which is 6%. And the time is also the same, which is 5 years. Let's plug it in there. So here, guys, it depends on the type of calculator that you have. A lot of times, the students make mistakes because when they raise the e to the power, they don't put parentheses. So to play it safe, you always put parentheses, because if not, you're going to get the wrong result. Okay, so anyway, the future value will give us $1,349.85, which runs off to $1,349.86. So after 5 years, there will be $1,349.86. So how much interest did you earn? Again, we use the same formula as before. So it'll be the future value minus the present value. So it's going to give us $349.86. So we got like $3 more, right? But this is like a small amount. So imagine the banks, when all the people, when they have a lot of customers that do the same thing, And it was only $1,000, but say it's 100,000, 200,000 that they want to deposit. You know what I'm saying? There'll be a lot of interest. That's why the banks, when you're going to borrow money from them, the compounded is more. For example, it can be daily, continuous, or weekly. And when you want the money to use the bank to use your money, when you deposit money, it's going to be compounded least amount of times because they don't want to give you that much interest. Okay. Okay, now compound interest continue. Example 6. I want to be earning an annual salary of 100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year, and the starting salary is negotiable. What salary should I request in order to meet my goal? So like I tell my students, guys, you always make it personal. So let's pretend that's you, that you want to earn 100,000 when you retire in 15 years. Okay, and you have been offered a job that guarantees the annual salary increase of 4% per year. So this is increasing every year, is increasing 4% every year for 15 years. So the starting salary is negotiable. So you can negotiate, and by using these type of problems, compound interest, you'll be able to negotiate and you'll be able to ask right now the money that you need, so that way you can get 100,000 when you retire in 15 years. Okay, so let's see how this problem works. Again, we're going to use a formula on the right because it's easier to enter in the calculator. So, but here, guys, I want to be earning an annual salary of 100,000 when I retire in 15 years. So check this out, guys. So here, the 100,000, you want it in 15 years, right? So that's my future value. So in other words, we're looking for, as the end says, what salary should I request in order to meet my goal? So you're asking for the present value. The future value is what you want in 15 years. That'll be 100,000. So my interest rate is 4%, which would be 0.04. My M, right, the compounded here, it says annually, right? So it's going to be 1. My T will be 15 because that's 15 years. So my I is R divided by M. 0.04 divided by 1 will be 0.04. And my N is M times T, which will be 1 times 15. It will give us 15. So let's plug everything in the formula. And again, here, let's do everything on the right side, right? So if we put parentheses 1 plus 0.04, close parentheses to the 15th power, it will give you 1.800943506. Now we divide both sides by 1.809435506, and this is my result. So it'll be 55,526.45. That's how much you need to deposit right now. Okay, now again, here's a formula again. Use your way to use your TI-8384 calculator by using the inverse key. Okay, so we're going to go here from the problem, from the formula, and this is how you're going to enter it in your calculator. You're going to input parentheses 1 plus 0.04, close it to the 15th power, and this is what you should see, 1.800943506. Then you're going to hit the inverse key, which is the key, I believe, let me see where it's located on your calculator. If you have the TI-8384, the inverse key will be on your first column. First column, 1, 2, 3, 4, on the 4th row. Okay, that's where the inverse key is. So once you hit that key, right, this is what you should see. Then you're going to enter the 100,000 and you get your result. And I repeat, this, the way I'm showing you guys is easier to follow because if you don't know how to put with the correct parentheses in the calculator, you're gonna more likely you're gonna get it wrong. And that's a mistake that a lot of students make, that they don't know how to enter it. That's why here on the bottom here in green, I'm showing you how to enter it. That way you're gonna get the right answer every time without actually leaving the calculator. Okay. And the book uses this formula here. Okay, this with this formula, the present value is equal to the future value divided by parentheses 1 plus I, close parentheses to the n power. you can actually put everything here in this formula, but you have to write, put the correct parentheses in order for you to get the answer right. Okay, but you can use either formula. Okay, now we're doing future value of ordinary annuities. And I repeat, like I said at the beginning, the simple interest, it used to be section 5.1 and the 12th edition of the current book that we're using. And the compound interest was 5.2. And this type of problems, the future value of an ordinary annuity, there was 5.3, and the present value was 5.4. But now on this newer edition, they put simple interest and compound interest in 5.1, and they put the future value and the present value of an ordinary annuity in 5.2. Okay, so that's why this is 5.2, the start of 5.2. If you notice, we have a different formula now. And again, there's going to be 7 things, right? The future value, the payment, the R, the M, the T, the I, and the N. The difference is the payment. Okay, the payment instead of the PV. Okay, now, like in real life, what are these? What's the main function of these type of formulas? The future value for ordinary annuities can be used to accumulate funds for some time in the future, but you must set regular deposits during that specific time. For example, you can set up an account like this one, a future value ordinary annuity. Say that you want to say that you can actually can save, like, say, $1,000 a month from your paycheck, right? It's money that you don't need, but you want to make some money out of it. So every month they're going to take that money out of your account, $1,000. That's every paycheck. And then you want to leave it there for like 5, 10, whatever time you want, say 15 years. So at the end of that time, you're going to get all your money back plus interest. Okay, that means future value for ordinary annuities. This is the way you use these problems here. These formulas. Here are more examples here. Again, let's say you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. You want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of those 20 years? Another example can be, let's say you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure you have enough money in 18 years for your child to attend college. I like to use these 2 scenarios because these 2 scenarios actually make sense to students. And I tell my students in class this week, I told them, hey guys, when you guys have, say when you're planning to have kids, and then say in 18 years, you go, more likely your kids are not going to be able to qualify for financial aid. Maybe you guys do, but not your kids. And then they asked me, why, Mr. Isasi? And I told them, it's because you're here you're in school to make money, right? You're in school to get an education, to make money. That's the purpose of coming to school, to get educated and to start making, earning like a nice, living by your check. So if you are successful, right, that means that your kids will not qualify for financial aid. So we have to start getting a plan. So your kids can have enough money to go to college. So this is a type of annuities that we can use to set up something in that fashion. So for the next slide, I'm going to use these 2 examples. Okay. Here's example number 1. Example 7. You can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. An investment company offers 3% interest for 20 years. If you deposit $1,000 at the end of every month, how much money will you have in 20 years, and how much interest will you earn? Okay. So again, this is my formula that we're going to be using. So we're looking for the future value, right? How much money we have in 20 years. So we're looking for the future value. The payments are going to be $1,000 every month. The interest rate is 3%, which will be 0.03. The M stands for compounding. Let's see, compound at the end of every month, so it's going to be 12. The time is 20 years. The I is R divided by M, 0.03 divided by 12, which will give us 0.0025. And the n is m times t, which will be 12 times 20, which will give us 240. So let's plug everything in, right? So again, here's how you do it in the calculator, guys, step by step. So this is the future value that you should be getting is $328,301, and no, it's gonna round off to $302. So this is how much you can have there. Okay, now I'm going to show you how to use in the calculator again without clearing or stopping, one steady flow until you reach your answer. So here's how you put in the calculator. You're going to start off by putting the numerator, just the way it is. You're going to input parentheses 1 plus 0.0025 close parentheses to the power of 240 minus 1. This is what you should see on your calculator. Then you're going to hit the division key, right? Because you're going to be dividing by 0.0025. After you do that, this is what your calculator should, what you should see on the screen of the calculator. After that, we're going to multiply that. We're going to hit times, and we're going to multiply by 1,000. So this is your answer. There were some students that actually, I believe last semester or last year, that they told me that the way I did this on the right, how to enter in the calculator, that it was very helpful because they would use animation and then they would try to do it on their own. And then, so before they got the answer, before they look at the answer, they would check and make sure that it was right. So they mentioned that this was very helpful for them to enter in the calculator. Okay. Now, so this was how much you will have in 20 years. $328,302. Okay, now how much did you actually put in there? Okay, so how many payments did you make? You make 240 payments, right? And each payment was for $1,000, so it's going to be 240 times 1,000, which will give us 240,000. So eventually, this is how much money you actually put in there. The rest of the money is actually interest that you earned. How much interest? So we subtract the future value minus the present value. The future value minus the total of the payments. So you're going to get back in interest $88,302, which is not bad at all, right? So this is how much money you got. Not saying for free, right? Because you invested it. Yeah, well, you can say for free, just by that's what you earned in interest. Okay, let's do another problem here. Okay, now here's where you're planning to sending your just born child to college, okay? Example 8, you are planning on sending your just born child to college when she turns 18. You want to have $250,000 in an account for tuition in 18 years. How much money must you deposit at the end of each quarter in an account paying 5% compounded quarterly? Okay, so there's my formula again. There's my 5 variables. But here, guys, we're looking for the present value, right? Because you want to have 250,000 in the future, so that's the future value. But so we're looking for the payments that you have to pay each quarter. So the future value will be 250,000. The interest rate is 5%, which will be 0.05. The M, right? The M stands compounded quarterly, so the M has a value of 4. The T will be 18 years, 18. Now the I is R divided by M, so it will be 0.05 divided by 4, which results in 0.0125. And the N is M times T, which will be 4 times 18, which will give us 72. Now we plug everything in there. Okay, now guys, from now on, we're going to use the inverse key, okay? When you're looking for payment, which is here, right? There's money on the left of the equal sign, there's money on the right, so that means we're going to use the inverse. So we start off by inputting the parentheses 1 plus 0.0125 to the power 72 minus 1 in the calculator. So this is the answer. This is what you should see on the screen. Now you're going to hit the division key because you're going to be dividing. Once you do that, you're going to see answer, right? This is what you should see on the screen of the calculator. Then you're going to enter the 0.0125, and then you're going to enter it. Once you do that, this is what you should see on the screen. 115.6736215. Now you're going to hit the inverse key. Press on the inverse key. That's what you should see. And you enter the 250,000. And this is what you should see. So that means that you have to deposit $2,161.25, which is not bad, right? It's about $550, or a little less than $550 a month, because quarterly means every 4 months or every 3 months. Okay, now let's do this, guys. So how much, this is extra information. How much money did you put into the account? So there were 72 payments of $2,161.25. So you multiply the 72 times the payment, which gives us $155,610. This is the amount of money that you put in there in those 18 years. But check this out, right? That can be your pocket, but you earned $250,000. So how much interest did you earn? 250,000 minus 155,610. So you earn almost $100,000 in interest, which is very, very good. So that money came from interest earned. Okay. Now comes the present value of an ordinary annuity. Okay, the difference is now is the present, and the other one was the future. For the present value of an ordinary annuity, and again, there's also 7 variables. But the most common use for this type of annuity is when you're going to purchase an expensive item like a car or more important, a house. We use these type of formulas to know your payment on a house or a vehicle. Examples: you want to purchase a car. What are your monthly payments, and how much will you end up paying? Also, you want to get an idea on the process of purchasing a house. What's the process? So there's a few things that you must know before you purchase a house, right? Or try to purchase a house. The first thing that you need is you need to have a job. If you have a job, right, then you might qualify to purchase a house. And also your credit score. You must have very good credit. The higher the credit score, the higher, the lower interest you're going to get. And the lower interest is much better because you'll be paying less money. If you have a high interest, you'll be paying more money. At the moment, I believe the interest rates are like between, I think, 5 and 7%. So that's kind of high. Back during COVID, they were like at between 2.5 and 3%. Okay, which was very, very good. And also, you must get pre-qualified for a maximum amount of a loan. What does that mean? It just means that before you want to go and look at houses with an agent, you must be pre-qualified, because you want to know what's the maximum amount that you'll be able to look at. So for example, say that you qualify for the maximum of a loan of, say, 200,000. Well, then the agent is not going to take you to nothing more than that. Because if you begin looking at houses that cost 300, 400,000, then which you know that you can purchase, right? So then once they begin showing you the ones that you can qualify for, they're not going to seem too attractive to you, because you got used to, looking at those expensive houses, more expensive than you could afford. That's why it's very important to get pre-qualified for the maximum loan. Okay, now let's do those 2 examples. Example number 9. Say you want to buy a car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and the loan is for 5 years? And how much interest did you pay? Okay, so here's a scenario, right? But nowadays, a new car that costs this much is not like a real good car. I think the cars also, they went up in value. Like a nice car will probably cost you between 40 to 50 or even more, 40 to 50,000. But let's pretend that this is the situation that you're on right now. Okay, you want to buy like a used car for this much. There's my formula. So we're looking for the payments. So the present value, guys, means that this is the amount that you're going to borrow from the bank, or from the dealership. They're gonna find a bank or a credit union to give you that much money right now in the present. So the present value is 26,500. The interest rate is 4.2%, and in decimal it'll be 0.042. Hey guys, right? The M, which is compounded, most of the times, or like 99% of the times, when it comes to a house or a car, the compounding will be 12 because it's monthly payments. So the M is going to be 12. The time is going to be in years, so it's 5 years. So the I will be R divided by M, which will be 0.042 divided by 12, which results in 0.0035. And the N, which is the M times T, will give you 12 times 5, will give you 60. So let's plug into the formula. And again, we're going to be using the inverse key at the end. So we first start by plugging all the numerator into the formula. It should be something like 0.18911,85031. After you see that, you're going to press the division key because you're going to be dividing by the denominator. You can enter 0.0035, and then when you enter it, it's going to give you 54.03385,802. Then you're going to hit the inverse key. Then you're going to enter the 26,750, and this is the result. Rounded out to your nearest penny is going to be 4.95 and 6 cents. So those are your monthly payments. Okay. Okay, now. So here, guys, you decide, right, if you can afford something like that. But most of the times, if you have a job, the dealership will kind of work with you. Okay, but you decide if you can afford that much, that much money. Say that you can, right? Say that you can only afford 400, then you have to give down like a down payment on the loan on the 26,750, so that way your payments can come down. Okay, now how much money did you actually end up paying for the car? So you made 60 payments of 495.06. So you multiply that, it's going to give you $29,703.60, which means that's how much you end up paying for the car. So how much was interest, right? So the interest, you can subtract it. You can subtract the value of the car from what you end up paying, which will result in $2,153.60, which is almost $3,000. That's how much interest you end up paying. Okay, now how can you avoid some of this interest? Every month, if you want, you can pay a little bit extra, because if you pay extra, it's going to go straight to the principal. So in the long run, you can avoid paying all this interest by giving something extra straight to the principal every month. And you can do that by calling the bank where you got the loan from, or actually going in person and giving a little bit of extra every month. And this will help you this will help you to save money on the interest that you must pay. Now comes the last example, okay? This is the one that most students like the most because it kind of gives them an idea what's the process in buying a house and stuff like that. So here's a scenario. You want to purchase a house for $325,000 with a fixed 30-year fixed rate at 3.9%. What are your monthly payments and how much interest did you end up paying? So again, the same formula. Right, so we're looking for the payments, so that's what we're looking for. So the loan was for $325,000, that's a present value. The interest rate was for 30 years. Most times the houses are for 30 years, 20 years, or 15 years. If you purchase a house and you want to pay it off in 15 years, your interest rate is going to go down, okay, like a point or so. But most of the times they're either 30 years or 15 years, and it's also at times they can give you a 20-year fixed rate. But in this case, it's a 30-year fixed rate. So what are the monthly payments? So let's find out. So my interest rate will be 3.9%. The M is 12. The T is 30 years. So my I will be R divided by M, 0.039 divided by 12, which will give us 0.00325. And the N is M times T, which will be 12 times 30, which will give us 360. So there's going to be 360 payments that you're going to be making. there's my formula, right? So we follow the same procedure as before. How to put in the calculator and in a steady flow without leaving or stopping the calculator. So again, you can enter the numerator. If you put 1 minus parentheses 1 plus 0.00325 close parentheses to the power of negative 360, here's what you should see on the screen. Then you're going to hit the division key, and you're going to enter the 0.00325. And this way you should see on your screen, which will be 212.0134431. Now you're going to get the inverse key, and then you're going to enter 325,000. And this will give you your monthly payments. So the payments will be $1,532.92. These are your payments. Okay, but this does not include the insurance, which it depends on what side of town you live. You also have to pay insurance for it. If you and also the property taxes. So all that, that'll be like another 2,000, I believe, or maybe 1,000. So your payments will be a little bit more than that, right? But without the insurance and the property taxes, this is how much your payments will be. Okay, now how much did you end up paying? So let's multiply the number of payments, which were 360, times the monthly payment. So you end up paying $551,151.20. That's a lot of money that you ended up paying extra, right? So you paid a little bit over $500,000. So to be exact, how much interest you paid, right? We subtract the value of the house from the total of the monthly payment that you made. This is going to give us $226,151.20. That's how much money extra you paid for the house. And again, how can you eliminate some of the interest? Is actually you can give extra every month for the principal, and this will actually reduce the interest that you're paying. Okay. Well, I want to thank you guys for this. Thank you for being patient, and thank you for joining today's Friday Math Happy Hour. If you have any questions, let me know. That way I can answer them for you. And if not, I want to thank you again, and I'll see you next week. Thank you. Patricia, can you hear me? Hello?
Yes, sir, I do.
Okay.
So let me go ahead and close. So if y'all come back later today, y'all can go and watch La Nouve, the EPC, El Paso, sorry, I keep thinking EPCC today, El Paso's new children's museum. That'll be happening at 1 o'clock. And then on the 8th, March 8th, we'll be having, for Happy Math Hour, we'll be doing exam 2 reviews. And for student success topics, we'll be going over EPCC publications. So we want to thank you for joining.
Thank you, Patricia. I was having trouble with my dongle.
Oh, no worries.
Connect and reconnect.
Pardon? All right. Well, I hope you all have a wonderful weekend. Thank you so much.